Hello everyone, I'm Maxine from Team 7. Today I'm going to give the final presentation about our team project, BioASQ system. First, let me introduce our team member. There are 4 people in our team. They are Chongshen Ma, Guan Wang, Yiran Fei, and myself. We spent about 5 weeks building up this BioASQ system. So, what is BioASQ system? You can easily tell from the name. This is a question answering system which can automatically answer biomedical questions. There are many types of questions can be asked, but due to limited time and effort, we only focus on a yes or no question. You can see here is an example question. It's from biophilia related to increased risk of miscarriage. The system will either give an affirmative or a negative answer after referring to a set of relevant documents. So how do we design the system? Let me show you the system pipeline. Since the system is heavily based on UEMA framework, it strictly complies to UEMA pipeline design, which follows the collection reader to annotators, then consumer workflow. As shown in the slides, the whole system is mainly divided into 3 parts. The blue block represents the collection reader, the white block represents the functions completed by annotators, and the red block represents the consumer. The collection reader simply reads in a list of questions, then store each question in CAS as question type object. These objects will be used by annotators further down the pipeline. We designed several annotators. Question annotator extracts important terms from question text using Stanford NER, then combines these terms to prepare a basic query for use in retrieving information needed for generating an answer. This query is used by multiple annotators to retrieve documents, concepts, and triples. The retrieved items are ranked according to their relevance. SNP annotator extracts sentences from the best ranked documents. Finally, the retrieved answers are used by answer annotator to generate an exact answer for the question. A consumer is used to output the exact answer as well as other intermediate results such as retrieved documents, concepts, and SNPs, in addition to the final answer, which are written in a JSON file. We also print out the results completed in the evaluation module. Before we go detail into the system implementation, I want to emphasize one challenge we have faced. There are only 8 yes/no questions in the provided datasets. It's too few data to evaluate the performance of the system. So we generate a new question set from the BioASQ database. We totally extract 85 yes or no questions and use them to test the system. Okay, let's look at how we implemented the system part by part and what strategy we have used. First is to build a query. Putting the raw questions directly into the search engine does not give us very good results, so we have to do some question pre-processing. The first method we try is to split the question task by space and get a question token list. But this method didn't perform well. An advanced technique is named entity recognition. Stanford NER2 is used to find nouns. To make it more meaningful, we added LinkPipe, which is a biomedical named entity recognizer. We also use multiple operators to build complex query. We try different ways to do this, like only using AND operator, only using OR operator, or and using AND and OR operators together. Let's look at performance comparison. The non-token method and complex query method both get a significant improvement compared to the original method. And because we care more about the document recall, so we choose the non-token method. That is, build our query as a list of non-tokens extracted by NER tools. Then let's move into document retrieval. For document retrieval, we take the query and search using the PubMed web service. The old strategy is use the order of documents from the web service directly and limit the total number of documents. But this brings a severe problem. Many retrieved documents are not that relevant to the question. In order to get a better answer, we have to store a large number of documents. This is very time and space wasting, so we came up with a new strategy. The new strategy is to get a large number of documents from the web service, then calculate scores for each document and sort the list. Now, how to calculate the score? We chose free document similarity calculation algorithm. That is cosine similarity algorithm, TF-IDF similarity algorithm, and G-card similarity algorithm, and compare their performance. After we rank the documents, we get a list of documents with higher scores. In this part, we use three different evaluation methods. Performance comparison is shown in the table. We can see that precision and recall are similar in all three rank methods, but the map performance is of great difference. And since we think the map evaluation is more important because it's an order evaluation, so we finally take the cosine method. In this way, we greatly improved the document retrieval performance and limited the number of retrieved documents to 30 most relevant documents. The next step in the pipeline is snippet retrieval. Snippet is used to help locate the exact answer. In order to extract snippets, we divide the retrieved documents into paragraphs and extract meaningful sentences by calculating their similarity compared to the query token list. Note that later several small snippets can be merged into a large snippet. We add a new attribute called negative words count to count the number of negative meaning words in each snippet. This turns out to be very helpful in our final generation of exact answers. Okay, let's move to the last part and also the most exciting part, answer generation. After so many steps, we can eventually generate an exact answer of yes or no, as mentioned before. To complete this task, we modify the type system to store the number of negative words. Let's look at the process of generation. First, we construct negative words dictionary. Words like cannot, isn't, unnecessary were included. For each extracted snippet, we detected negative words and tagged the snippet. If the target sentence just has one negative word, this sentence will be labeled as negative. If the sentence does not contain any words in dictionary, the sentence will be labeled as positive. At first, the accuracy of final exact answers are low. We found that this is because we only consider the best ranked snippet. If the best ranked snippet is affirmative, we decide the answer for the question to be yes, otherwise to be no. In order to get a more objective decision, we adopt a voting strategy. For each query, we generate an answer for every snippet and count the total number of the yes answer and the no answer. If there are more yes answers, then we think the exact answer is yes, otherwise return no. In this way, we significantly improve the correctness of the results. Let me show you our demo. We test the system on the original 8 yes or no questions. It takes a little while to run the system. With the original test set, the accuracy is increased to 100%. Amazing, right? However, we must point out that this result relies on great quality of retrieved snippets. If the snippets are not relevant enough, the voting approach will fail either. Here is our performance improvement. Let's review the methods we used for the answer generation. First, construct negative words dictionary. Second, negative words detection and sentence tagger. Third, counting and voting mechanism. When we did error analysis, we found a special case. For this question, no documents are retrieved, thus no snippets are extracted. Because there is no enough support, we set the default answer as no. Actually, this is very reasonable, because the ideal answer also indicates a no answer. The perfect performance testing on the small question set might be kind of accidental, so we test on the large question set. The system turns out to be great as well. The accuracy can reach approximate 83%. Okay, this is the end of our implementation work. When we reflect on the whole project, we think good team management is the most important factor for our success. We use agile development. Several management tools such as Gantt chart, backlog, and retrospective were used. All of them are very efficient approaches and help us doing better work. This is our presentation. Thank you for listening.